So example 4 in the workbook is given a graph, and then the dashed line represents the original function fx, and then the solid line represents the function after the transformation. And also they specifically give you the points, like the point A and B, they're both on the original function. So the coordinate is right here, 1, 1 for A, 2.5, 1/2 for B. Then transform into the A prime, -1, 4, and the B prime, 1, 3, respectively. So basically, it's kind of a question, you have to work around, and instead of telling you that all the numbers, and they ask you to figure out the transformation, they actually tell you the points before and after the transformation, ask you to figure out all these numbers, how they are transformed, what kind of transformation, how many, what's the effect of compression or stretch, and what's the units translation, left or right, or up or down. So if you understand how the points are transformed, and then we can figure out this. Okay, now as I mentioned in class, so any kind of transformation, you can just basically there's some calculation between the transformed point and the original point, right? So if the original point, I make it's x0, y0, it is on the original fx, and then after it's transformed into the new function, I just call x and y, so they should have a sort of relation between x0 and y, y0 and y in this kind of relation. So the A representing the stretch or compression, but it's for negative, it also involves reflection. So same thing happens to y as well. So let's just try to figure out A and B, C and D, and using the points given. So we just plug in for the horizontal coordinate. So this is actually the x0, right, the 1, and then we put it here. So put it here, and then y0, x is -1, so we put it here. So we got an equation involve A and B, and then look at the second point. So the x0 is 2, x is 1, right? And then we plug in here the same equation as well, so we create another equations. So it forms the system of two linear equations. So you can easily solve these two equations by subtracting the two equations you get as A, and then substitute it back to get as B. So you can solve that. So I don't want to go over the detail about how to solve this system of equations. Same thing happens to the y equals c y0 plus d if you plug in the two y coordinates. So this is y0, and this is y, and this is y0, this is y again for the second point. So also you can form two equations here, and if you solve, you can get a c equals 2, d equals 2. So basically, if you put it back, A, B, C, D, you can find out the relation between the new point represented by x and y, and with the older point represented by x0, y0, right? So if you have this relation, you can tell definitely how the transformation happened. For example, if you look at it horizontally, x equals to x0 minus 3. Basically, you multiply 2 first, means you should have a horizontal expansion by effect of 2. And after you done the expansion or stretch, then you subtract 3, and means you move left 3 units, right? Vertically, you have 2y0, means you have vertical expansion by 2, and then plus 2 means you have 2 units up. Okay, now you can, if you verify it's absolutely true, right? For example, the original point is 1. You plug in 1 multiplied 2 minus 3 should be -1. So that's exactly how you get a -1, right? And if you test another point, so for the point B, the vertical y coordinate is 1/2. Plug in here, so 2 multiply 1/2 equals 1, 1 plus 2 equals 3. So that's how you get a 3. So this equation is really explains what the transformation really happened. It's just a simple operation: multiplication, then subtraction, multiplication, then addition, right? But in if you isolate the x0 and y0, and then you just express the relation in a different way, and you can actually put it back to create as a new function. So this is y equals fx. That's the original function, right? If the x replaced by this, y replaced by this, so you just created the transformed function, right? So here is just replace x and y directly, and this one is just if you isolate the y, so you can form an equation, in make the y in explicit form, so like the normal form we see.